So in this video, we are going to see how to find values of inverse trig functions. So the first question here, the first set of questions that we see are asking us to find the values of some inverse trig functions, right? All right, let's look at it. The first question is sine inverse of 0. So here you have to remember that the input to an inverse trig function, so the input is some real number and the output should be the angle. So when the question asks you sine inverse of 0, what are you going to look at? You know how the graph of a sine function looks like. Now, if you're just answering this question, what are all the angles for which sine has a value of 0, right? That is what this is asking you. You see that all of these values in here are going to be a possible solution. However, we have restricted the domain of an inverse function for sine to be between negative pi over 2 and positive pi over 2. So this is the interval in which we have defined it for. So in that interval, the only answer that we have is 0. Then we have cosine inverse of 1. So here I'm going to write this down so that you have this with you. So what I want you to look at is the, the domain and the range. So the domain, the range. So the domain where sine is defined for an inverse is going to be between negative pi over 2 and positive pi over 2. And the range corresponding is negative 1 to 1, which means sine inverse of x can take negative 1 and 1 as its input and can only give you values between negative pi over 2 and positive pi over 2 as its output. So this is a restricted domain. Now, likewise, if you want to move to cosine, so what you're going to have for cosine would be the restricted domain for cosine is 0 to pi. The corresponding range is negative 1 to 1. For cosine inverse of x, negative 1 to 1 is the input and 0 to pi will be the output. Now, for tan inverse, the domain and range for tangent function is going to be the domain is going to be negative pi over 2 to positive pi over 2. However, the two values themselves are not included because tangent becomes undefined at those values. So the range is negative infinity to infinity. And for tan inverse of x, it takes any real number input and the output is in the interval negative pi over 2 to positive pi over 2. So keep this in mind as you answer these questions. Now, cosine inverse of 1. So basically, think about it this way. How are you going to answer this question? The way that you're looking at this question is it on a little bit. So if the question asks you what is cosine inverse of 1 is what, that is the question, the way that you are processing this would be, let me take all of these problems down somewhere and then I will just work on this so that you're able to see this. got you here. Cosine inverse of 1. So basically, how are you going to answer this question? The way that you're going to answer this question is this output is some angle theta, correct? So that is your answer. So you are going to look at it as cosine theta is 1. But you have to keep in mind that this angle theta must be between 0 to pi. So that is our domain restriction. So the question you're going to ask yourself is, for which angle in the interval 0 to pi, cosine has a value of 1? And the answer is pi over 2. So that is your answer. Likewise, here you're going to ask for 14, the same question. In the interval 0 to pi, where is cosine -1? The answer will be pi. Okay? Sine inverse of -1. So in the interval -pi/2 to +pi/2, where is sine -1? The answer is -pi/2. So as you're answering the sine inverse questions, keep in mind that we are looking at these two quadrants, quadrant 1 and 4. And sine is an odd function. So basically there is a reflection about the x-axis. So if you want to do this is, so you know that this angle is pi/2, this angle is -pi/2, and sine pi/2 is 1, sine -pi/2 is -1. Likewise, you have pi/6, you're going to have sine value of 1/2, and -pi/6 is -1/2, and so on. So you can just flip the sign and that would work for you. Tan inverse of 0 is 0 because in the interval -pi/2 to pi/2, tangent is going to be 0 at the angle 0. Okay? So from now, I will just do all the odd problems. 17. Question number 17 is asking you to find sine inverse of √2/2. So sine inverse of √2/2. Again, the question you're going to ask yourself is, in the interval -pi/2 pi/2, where is sine √2/2? And the answer is pi/4. 19. What is tan inverse of √3? Again, this is going to be pi/3 because in the interval -pi/2 to pi/2, tangent is √3 when theta is pi/3. Okay, let's move back and just get out the questions. 21. 21 is cosine inverse of -√3/2. But then if you want, you can make this into some angle theta. So it is cosine theta is -√3/2. So you're just looking at for which angle in the interval 0 to pi cosine has a value of -√3/2. So if you think about this, cosine is defined in this interval 0 to pi. -√3/2 is going to be this angle, right? And that angle is 5 pi/6. 23 is cosine inverse of √2/2, and that is 5/4. Okay, question number 25. Question number 25 is tan inverse of -√3/3. So to find tan inverse of -√3/3, again, you have to look at tangent is the same way as sine. So you're going to have in these two quadrants. So if tangent of a negative number will be a negative angle, right? So for √3/3, we are looking at this angle, and that is -pi/6. All right. So that is the first set of questions. Now we're going to move on to the second set of questions. So let us see what the second set of questions are. So here you have to find the exact value of a composition, all right? So exact value of a composition. First is this, I'm going to write all of these down. So before I write these down, let me tell you a little bit of fundamentals here. So remember this. Sine, so when you compose sine with sine inverse, you have to get the original input x back. Now, this only works if the input x is in the interval -1 to 1. Okay. Likewise, sine inverse of sine x will also be equal to x, provided x is in the interval -pi/2 to pi/2. So you can always force this. So this kind of a setup will always have a solution, because remember that the actual original input into a sine function is all real numbers. So this is always going to have an input. Whereas the first scenario will only have an answer if the x is between -1 and 1. Anything else is going to give you an undefined. So now knowing this, and we will write it for everything else. So for tangent, you can input any real number. So now knowing all of these, let us go ahead and answer starting from question number 29. So question number 29 is, it's not 29, 39 is cosine inverse of cosine 4 pi over 5. The first thing you need to do is, where is 4 pi over 5? So 4 pi over 5 is less than pi. So 4 pi over 5 is in the second quadrant. Now, which is within the interval for which cosine is defined. Therefore, my answer is just 4 pi over 5, and I'm done. 41. I'm just getting the question here. So the question is tan inverse of tan -3 pi over 8. Again, you have to find out, where is -3 pi over 8? Is it between -pi over 2 and +pi over 2? So that is what we're trying to find out. Now again, remember, where is tangent defined? Tangent is defined between -pi over 2 and +pi over 2. But this denominator is over 8. So feel free to convert this to over 8. So this is -4 pi over 8, and this is +4 pi over 8, right? You can do that. So if you're converting this, what are you going to have? So for example, if you have pi over 4 is 2 pi over 8, isn't it? So that means as you're moving along, -3 pi over 8 is somewhere here. So which means it does belong to the interval that I'm concerned about. Therefore, the answer is -3 pi over 8, and I'm done. 43. Okay, now that you get the basics, I just probably will just go here because I don't have to keep flipping back and forth. Okay, 43. So question number 43. Now 9 pi over 8. So 9 pi over 8 is definitely not between -pi over 2 and +pi over 2, right? So now I have to do a little bit of work. Before I do the work, let us see where 9 pi over 8 actually falls. So where is my 9 pi over 8 going to be? It is a little bit over pi, isn't it? Because pi itself is 8 pi over 8. So that means this angle is going to be somewhere in the third quadrant. This is 9 pi over 8. So now I know that I want my restricted domain to be between negative pi over 2 and positive pi over 2. So what I'm going to do is I'm going to find an equivalent angle in the interval negative pi over 2 to pi over 2 for which sine will have the same value. Okay, so where is this equivalent angle? So to find the equivalent angle, I have to first know in the third quadrant is sine positive or negative? It is negative. So my equivalent angle is going to be in the fourth quadrant. So I want this is my equivalent angle, right? So the angle that I'm interested in finding is this one. So this is my angle that I'm interested. So what do you think that angle is? In order to find that, find out what this small sliver is. This is pi over 8, isn't it? Because pi itself is 8 pi over 8. That means that angle is pi over 8, which tells me that this one, which is on the other side, is going to be negative pi over 8 because it is a reflection, isn't it? So that angle is negative pi over 8. So my answer to question 43 will be negative pi over 8 is the answer to 43. So now let's do 45. So 45, negative 5 pi over 3. Now here, you can do it one of two ways. Cosine is even function. So if you want, that is, you can rewrite question number 45 like so. All right. Now find out where is 5 pi over 3. 5 pi over 3 you should know. So pi over 3 is in first quadrant, 2 pi in the second quadrant, 4 pi over 3 in the third quadrant, 5 pi over 3 is here. It is in the fourth quadrant. Now in the fourth quadrant, cosine is positive. So if I want an equivalent angle between 0 to pi, then I'm going to move up here, right? And that angle is pi over 3. Then that takes me to 47. 47, 4 pi over 5. Where is 4 pi over 5? 4 pi over 5 is here. Okay. So, uh, so if I want to find a value for tangent, I have to push it to this interval, negative pi over 2 to positive pi over 2. Now, tangent is negative in the second quadrant. That means my equivalent angle needs to come from here. Okay. So what is that angle? So if you want to find that angle, so remember this whole thing is the whole thing. By whole thing I mean this whole thing is pi, right? And out of that 4 pi over 5 is already taken, which means this angle has to be pi over 5. But because I'm writing it as a negative angle, it is going to be negative pi over 5. 49. Tan inverse of tan negative 2 pi over 3. So where is 2 pi, negative 2 pi over 3, negative 2 pi over 3 is here in the third quadrant. Their tangent is positive. So this is negative 2 pi over 3. So if I want to get an equivalent angle, I need to go to the first quadrant because again, tangent is positive there. And this angle will be pi over. Okay. That takes me to the next problem, 51. Can be rewritten as cosine inverse of cosine pi over 4. And the answer is pi over 4 because pi over 4 is between 0 to pi. So no work was necessary. Now that takes me to 53. Tan inverse of tan pi over 2. Remember, tan pi over 2 is undefined. It is not in the domain. So I don't have to worry about that. Now that takes me to 55. Sine of sine inverse of 1/4. Here I have to make sure that 1/4 is between negative 1 and 1. It is. So the answer to 55 is just 1/4. 57, I have to make sure that the number is any real number, so no problem. The answer is 4. 59, cosine of cosine inverse 1.2. Remember, there is no angle for which cosine is going to be 1.2 in value. Therefore, it is not defined. And finally, 61, tan of tan inverse of pi is just pi because tan inverse can take any real input. Okay, so now that takes us to these set of problems where we are trying to find an exact solution. So remember, for all of these problems, my goal is to get the inverse function by itself on the left side. So I want it to be by itself. So I'm going to take a minute to rewrite my question as sine inverse of x is pi over 4. So what I did is I divided both sides by 4. Then I can write the answer x is equal to root 2 over 2 because sine pi over 4 is x, which means x is root 2 over 2. 73. Again, I'm going to take a moment to rewrite this as put the 3 over here. So then my question becomes cosine 2 pi over 3 is 2x. And what is cosine 2 pi over 3 is going to be negative root 3 over 2 is 2x. That means x is negative root 3 over 4. Okay, divide by 2 on both sides. Takes me to 75 now. So 75 is 3 tan inverse of x is pi. So let's do that. 3 tan inverse of x is pi. So divide both sides by 3. I get pi over 3. Rewrite this. So tan pi over 3 is x. And tan pi over 3 is root 3. So my x is root 3. So in the next problem, I want to get all, I'm going to isolate it so that all the cosine inverse of x is in the left-hand side. So what I have here is 4 cosine inverse of x minus 2 cosine inverse of x is 2 pi. So combine the like terms. So I get this. Divide by 2, I get this. So cosine of pi is x. So that means x is negative 1. The next problem is here. We have to find all of these composite functions. Let me see how many we are doing here. So we need to do 39 to 61. Hmm. So the first problem here is cosine of sine inverse of root 2 over 2. Okay, so this is a unit circle value. So this is pretty straightforward for me. Sine inverse of root 2 over 2, I know is pi over 4, right? So cosine pi over 4 is root 2 over 2. So that's all I need to do. Now 35 is tan of cosine inverse of negative root 3 over 2. So negative root 3 over 2, I know second quadrant. So cosine of 5, I'm sorry, tan of 5 pi over 6. Because remember, cosine inverse of negative root 3 over 2 is 5 pi over 6. And tan 5 pi over 6 is negative root 3 over 3. 37 cosine over root 3 over 2, which is 2 root 3 over 3. 39 cosecant of tan inverse of 1. Again, where is tan inverse 1 in the first quadrant? Pi over 4. So I have cosecant of pi over 4. Now, what is cosecant? Cosecant is nothing but 1 over sine pi over 4. What is sine pi over 4? Root 2 over 2. So then if I flip it, I'll get 2 over root 2, which is root 2. 41, I have sine of tan inverse of negative 1. Tan inverse of negative 1 is negative pi over 4. And sine negative pi over 4 is negative root 2 over 2. 43. Secant of sine inverse of negative half. Again, sine inverse of negative half, fourth quadrant, is negative pi over 6, right? And secant is an even function. So secant negative pi over 6 is the same as secant pi over 6, which is 1 over root 3 over 2, which is 2 root 3 over 3. Okay. Okay. Next, 45. Cosine inverse of sine 5 pi over 4. Sine 5 pi over 4 second quadrant, no, third quadrant, cosine, sine is negative. So this will be cosine inverse of negative root 2 over 2, right? And then now this puts cosine in the second quadrant. So that is going to be 3 pi over 4. Do you understand? So this is going to be the value of this is from the unit circle, you know, is negative root 2 over 2. But if you're going to take the cosine inverse of that, remember you had to force it to the first and the second quadrant, and cosine is negative in the second quadrant. Therefore, this is your answer. So 47, sine inverse of cosine negative 7 pi over 6. Which is the same as sine inverse of cosine 7 pi over 6. Cosine 7 pi over 6, third quadrant, right? Third quadrant, that is going to be cosine is negative. So this will be sine inverse of negative root 3 over 2. And sine inverse of negative root 3 over 2 is negative pi over 3. 49. Tan of sine inverse of 1/3. Now 1/3 is not a unit circle value. So what am I going to do here is I'm going to construct a right triangle. So what this is, I'm going to say let sine inverse of 1/3 be some angle theta. If that is true, then sine theta is 1/3, right? So sine theta is 1/3. So let me say that my angle theta is here. 1/3 is what? Y over R, right? So Y is 1, R is 3. So that means I don't know what X is. So to find X, I'm going to do X squared plus Y squared is R squared. So X squared plus 1 squared is 3 squared. X squared is 9 minus 1, 8. So X can be either plus or minus root 8 or plus or minus 2 root 2. So there are two possibilities. Now I have to narrow it down to 1. How do I do that? I know that if sine is sine inverse of this positive number puts already it in the first quadrant, and in the first quadrant x is positive. So that's what I have. Now go to your original problem. For this angle theta, tangent is nothing but y over. Okay. In these questions, we are going to be solving equation and we're going to give a solution in the interval 0 to 2 pi. So the first thing I'm going to do here is I'm going to make sure that the left side only has the trig function in there, meaning I'm going to first subtract the 3 from both sides and I'm going to divide both sides by 2. So sine theta is negative half. I look at my unit circle and find that sine theta is negative in the third and the fourth quadrants, and the corresponding angles are 7 pi over 6 and 11 pi over 6 are where sine theta is negative 1/2. And that's it. Here I do the same thing. I subtract the 1 first, I divide, and then I have the same scenario, meaning same solution. Next problem. I'm going to subtract the 1 from both sides. Tan theta is negative 1. So tan theta is negative in the second and fourth quadrant. So which means in the second quadrant, it is 3 pi over 4. And in the fourth quadrant, it is 7 pi over 4. And those are the two angles. Next one, do the same thing. Subtract the 6, divide the 4. So when secant is -2, is the same as saying cosine is -1/2. Okay? So where is cosine negative? In the second and third quadrants. So in the second quadrant, the angle is 2 pi over 3. And in the third quadrant, it is 4 pi over. Subtract the 2 first for the next one. And then divide. The cosine is -√2 over 2. So where is cosine -√2 over 2? It is in the second and the third quadrants. Again, the angles will be 3 pi over 4 and 5 pi over. Okay, so the next question you have to watch out. First thing you're going to do is divide the 4, and then you're going to take the square root. Square root of 1/4 is 1/2. So now you are going to have, so you have to find all the angles theta for which cosine is either +1/2 or -1/2. So now if you look at this, that is going to be this angle, +1/2. This angle, -1/2. -1/2, +1/2. And what are the angles? The angles are pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over. So next one, I'm going to do the same thing. First, I'm going to move the 1 over. Then I'm going to divide the 1. Divide the 2. Then I take the square root. I get plus or minus √2 over 2. So 1 over √2 is √2 over 2. So then I find all the angles for which sine is either so anyway, if you're having problems with this, I have sine theta is plus or minus square root of 1/2, which is plus or minus 1 over √2, which is plus or minus √2 over 2. Okay? So all the angles are going to be multiples of the pi. So pi over 4, 3 pi over 4. I said multiples of pi over 4, odd multiples of pi over 4, sorry. So 5 pi over 4 and 7 pi over. Okay, next one. Sine 3 theta is -1. Where is sine -1? It is -1 for the angle 3 pi over 2. So it is 3 pi over 2 plus 2k pi. I divide by the 3. So I get my solutions are going to be pi over 2 plus 2k pi over 3, right? So the first thing I do is k is 0. Then theta is pi over 2. Then I make k equals 1. That means, and theta will be pi over 2 plus 2 pi over 3. So how much is that? That is 5 pi over 6. 7 pi over 6. Right? And then I need k is 2. Then I have pi over 2 plus 4 pi over 3. So that will be 3 plus 8, 11. And I don't have to go any further because if I go k equals 3, then I'll be actually adding 2 pi, which I don't want to because my interval is from 0 to 2 pi. So I stop here. So I end up with 3 solutions now. The 3 solutions are pi over 2, 7 pi over 6 and 11 pi over 6 are the three solutions. Okay, here cosine 2 theta is negative half, which means 2 theta, so negative half. So first solution is in the second quadrant. In the second quadrant, that will be 2 pi over 3 plus k pi. Then in the third quadrant, it will be 4 pi over 3 plus 2k pi. I divide by the 2, I get pi over 3 plus k pi, and then I have 2 pi over 3 plus k pi. I just divided by 2 on both sides. Then, what are my solutions? When k is 0, it is pi over 3. When k is 1, it is 4 pi over 3. I cannot go more than that, so I stop. Then I move on to this side. The first solution is 2 pi over 3. Then when k is 1, I add 2 pi over 3 plus pi, and that is 5 pi over 3. I can't go any further, so these are my solutions. Okay. So in the next one, it is asking you for a general solution. So in the general solution, you will just write that theta is nothing but, so sine is positive in the first and second, right? In the first quadrant, it is going to be pi over 6 plus 2k pi. Or in the second quadrant, it will be 5 pi over 6 plus 2k pi. So these are all possible answers. Likewise, here theta can be negative root 3 over 3. So that puts us in either the second or the fourth quadrants. So in the second quadrant, it will be what? Second quadrant is going to be 5 pi over 6 plus k pi, or it will be 11 pi over 6 plus k pi. Okay. So it's the same thing. I don't even have to write this one because it's k pi. I can just leave it with this. Okay, cosine theta is 0, meaning it is going to be theta is pi over 2 plus 2k pi, or it is 3 pi over 2 plus 2k. Okay, then we're going to solve some equations. So here it's quadratic in form, so I factor the cosine theta, then I get this as my factor. Now that it is in the factored form, I equate each factors to 0 and solve. So cosine theta is 0, means theta is either pi over 2 or 3 pi over 2. Here I simplify, I get cosine theta is negative half, which means theta is either going to be 2 pi over 3 or 4 pi over 3. So put them all together and write a solution. So next one. Again, this is quadratic in form. So if you multiply these two, you get negative 2. So I can rewrite it like so. After equate each factor to 0. So based on this, write your solution. Sine theta is 1 for pi over 2. Sine theta is negative half for 7 pi over 6 and 11 pi over 6. Okay, next one, I'm going to just set them equal to 0. Tan theta minus 1 is 0. Secant theta minus 1 is 0. Tan theta is 1. Secant theta is 1. That means theta is either pi over 4 or 5 pi over 4. Right? Secant theta is 1 when cosine theta is 1. And what is cosine theta 1? For 0 or 2 pi, but 2 pi is not in the interval. So these are my 3 solutions. Last problem. So I'm going to rewrite them all in terms of cosine theta. So remember, sine squared theta plus cosine squared theta is 1. That means sine squared theta is 1 minus cosine squared theta. So I'll write it like so. I'll write one more step. Now, bring it out of the parentheses. Combine like terms. Bring everything to the left. Cancel the like terms. Factor. Equate the factors to 0. The solution. Cosine theta is 0 for pi over 2, 3 pi over 2. It is negative half in the second and third quadrants. For 2 pi over 3, 4 pi over